All right, today we're going to be working more with polynomials. And their factors and zeros. So you've got about four different types of problems that we're going to cover today, and then I'm going to give you some practice to do. And the practice that I give you today is going to actually be your study guide. You don't technically have a printed out sheet that says study guide, but the problems that I give you as your practice for today will serve as your study guide. And these notes, all right? These notes and the notes from, I don't know, Tuesday, I guess we were here last. So, first type of problem you're going to be doing today. You are going to be asked to write each polynomial in factored form. And then it'll say check by multiplication. Which means that you can check your own answer by simply multiplying your factors. So here's your first example. We've got an x to the third plus a 7x squared plus 10x. All right, and if we got to write this in factored form, what we're going to do is we're going to factor it. And as you can see, each term in this trinomial has an x in it. So we're going to factor out an x. And when we factor out the x to decide or determine what goes inside these parentheses here, you just take each of the terms and you divide it by the x that you factored out. So if you take x to the third and you divide it by x, you get x squared. And you get plus 7x squared divided by x is 7x. We get another plus. And then 10x divided by x, that's 10. So now that's step one. You factored out an x. The second thing that you want to do, or the next step, is going to be to factor this trinomial that's inside the parentheses. So you're looking for two numbers that multiply to 10, but add to 7. Multiply to 10 and add to 7. So your factors of 10 are 1 and 10 and 2 and 5. So the only factors you can use are these two. So this factors to x times x plus 2 times x plus 5. All right, and there's your polynomial in factored form. Now, to check this by multiplication, you would take your factored form and multiply it out, which means here's your check. We got x times x plus 2 times x plus 5. And if you distribute this x first, your x times x is x squared, and x times 2 is 2x. And you've still got to multiply that by x plus 5. So that check would be x squared times x, which is x to the third, x squared times 5, which would be positive 5x squared. Then we've got this 2x times x, 2x squared. And then we've got the 2x times the 5, which would be positive 10x. And now you can combine your like terms here in the middle, your x squareds. And what you're left with is x to the third plus 7x squared plus 10x. All right, since that is the same as what you started with, you factored correctly. All right, so we're going to do one more of these. We've got an x to the third plus 8x squared plus 16x. And again, each term in the trinomial has an x in it, so we're going to factor that out. X to the third divided by x is x squared. 8x squared divided by x is 8x. And 16x divided by x is 16. All right, so now we're looking for factors of 16 that add to 8. And our factors of 16 are 1 and 16, 2 and 8, 4 and 4. So the only two factors that will add up to 8 are the 4 and the 4. So this becomes x times x plus 4 times x plus 4. And then to simplify, this x plus 4 times x plus 4 becomes x plus 4 squared. So x times x plus 4 squared is your factored form. For x to the third plus 8x squared plus 16x. Any questions there? All right, second part of your assignment. Find the zeros of each function. All right, we did this earlier when we were working with quadratics. We're going to find the zeros of the function, and they're giving you the function in factored form. So if you get the function y equals x minus 1 times x plus 2, this is the factored form of a polynomial. All right? This is probably like x squared plus x minus 2. The zeros of the function are when you take each factor and you set them equal to 0. All right? So you take x minus 1, you make it equal to 0. And you take x plus 2, and you make it equal to 0. And you solve for x in each of these. So you add 1. X equals 1. You subtract 2. X equals negative 2. All right? So these, your zeros, find the zeros of each function. The zeros of this function are 1 and negative 2. The zeros, remember, that's where the graph hits the x-axis. It's where the graph hits the x-axis. Now, to kind of show you what the next segment is going to look like a little bit, if we were to take this y equals x minus 1 times x plus 2, all right, and we took this right side and we multiplied it, I want you to see what's going to happen here. If you take x minus 1 times x plus 2, your x times your x is x squared. Your x times your 2 is positive 2x. Your negative 1 times x is negative x. And your negative 1 times 2 is negative 2. And when you combine these like terms, you get x squared plus x minus 2. So since y was equal to x minus 1 times x plus 2, y is also equal to x squared plus x minus 2. And why I'm saying this is because in the next type of problems you're going to get, or you're going to see, you're going to be given the zeros, all right? And from the zeros, you're going to be asked to write the function in standard form. So I want you to see where these zeros came from. These zeros of 1 and negative 2 came from the factors x minus 1 and x plus 2. And x minus 1 times x plus 2 came from this quadratic function right here. Because x minus 1 times x plus 2 is equal to x squared plus x minus 2. Okay? I'm hoping that makes a little bit of sense to you. So let's find the zeros of one more function. Let's do the zeros of y equals x plus 1 times x minus 1 times x minus 2. All right, so here's your zeros. Most of you guys, you're going to be good enough at this that you don't have to write out each individual equation. I mean, if you look at this, your zeros are going to be negative 1, 1, and positive 2. And here's why. Because when you set x plus 1 equal to 0, and x minus 1 equal to 0, and x minus 2 equal to 0, and you solve for x in each of these equations, here's your x equals negative 1. Here's your x equals positive 1. And here's your x equals 2. All right, so if you got 3 factors, you got 3 zeros. Those are your zeros. That is how you get each zero from each factor. All right, and one more of these. We got y equals x times x plus 5 times x minus 8. All right, again, you got 3 factors. Don't forget about this, or please be careful when this is sitting out here by itself, because that x is a factor. All right, so when you set each factor equal to 0, you got to set x equal to 0. It's that one. You got to set your x plus 5 equal to 0, and your x minus 8 equal to 0. So your second 0 is x equals negative 5. And your third 0 is x equals 8. So your 3 zeros (0, -5, and 8. Everybody all right with that? All right, then you're going to be asked to write a polynomial function in standard form with the given zeros. So now you're going to be given the zeros, and you got to work backwards. So your x is equal to, you got a 5, a 6, and a 7. All right, those are your 3 zeros. If those are your 3 zeros, the next thing you want to do is write your factors. All right? So if you remember this x plus 5 equals 0, well, if -5 is a 0, then x plus 5 is a factor. If +8 is a 0, then x minus 8 is a factor. So since all of these zeros are positive, here's what your factors are going to look like. You're going to have an x minus 5 times an x minus 6 times an x minus 7. So there's your function in factored form, given the zeros. And now you have to multiply. So the first step in your multiplication is to take your first 2 factors and multiply them. So you've got an x times an x, which is x squared, and an x times a -6, which is -6x. -5 times x is -5x, and -5 times -6 is +30. So that's the product of your first 2 factors. And let's clean this up. We still got to multiply by x minus 7, and we're going to combine these like terms right here. So we get x squared minus 11x plus 30. We still got to multiply it by x minus 7. So now, take your x squared times your x, and you get x to the third. And then your -11x times the x, and you get -11x squared. And then your 30 times the x, and you get +30x. And now you have to repeat the process. You got to take your x squared and multiply it by -7, which is -7x squared. And then your -11x times the -7, which would be +77x. And then your 30 times your -7, which would be -210. And now you have to be careful when you're combining like terms, okay? So you got your x to the third, and there's nothing else to the third, so there's nothing to combine it with. And then here's your squareds. You got this -11x squared and the -7x squared. Your -11 and your -7, that's a -18x squared. And then you got to combine this 30x and a 77x. And that gives you positive 107x. And then your last term out here is this negative 210. All right? So there's your polynomial function in standard form with these three given zeros. The steps are, you take the zeros, you write your factors, take your factors and multiply. Combine like terms, and make sure that in your last step that your exponents are in descending order. All right? Your exponents have to be in descending order. Anybody have any questions on that? Taking the zeros, writing the factors, then writing the function in standard form. All right, and then the last part of your assignment today. Find the zeros of each function. State the multiplicity of multiple zeros. Find the zeros of each function, state the multiplicity. Here's what that means. Multiplicity is how many times a zero shows up after factoring. All right, and it's not the number zero, it's the zero of the function. And here's what I mean. If we're going to find the zeros of each function, then we're going to state the multiplicity. And let's say we got y equals x plus 3, and this is cubed. If y equals x plus 3 cubed, then y is equal to x plus 3 times x plus 3 times x plus 3. So your zeros are x plus 3 equals 0, and you subtract 3. And x is equal to negative 3. All right, so this is a 0. X equals negative 3 is a 0 of this function. It's the 0 we're talking about here. All right, so find the zeros of each function. Your zeros of this function are negative 3. State the multiplicity. So your zeros are negative 3 with multiplicity of 3 because it showed up 3 times, or it will show up 3 times if you solve for each of these factors. All right? That's what multiplicity means. It's how many times a 0 shows up after factoring. Yep. Where? Down a little bit? Let me know when I can move it up. There, we good? All right. All right, so let's take a look at this. Y equals 2x plus 3 times x minus 1 squared. So this is the same as 2x plus 3 times x minus 1 times x minus 1. So we set the factors equal to 0. So we get a 2x plus 3 equals 0. X minus 1 equals 0. So subtract 3 here. 2x is equal to negative 3, and then divide by 2. X is equal to negative 3 over 2. And then in this second and third factor, they're both the same, so we add 1. X is equal to 1. So your zeros are negative 3 over 2 with multiplicity of 1, and positive 1 with multiplicity of 2. Just means that it shows up twice as a 0. All right. Any questions on that? Finding the zeros and determining their multiplicity. Well, a lot of it's related. So, okay. Here's what we're doing next. Your study guide for quiz 11. Is to make sure that you can do every problem that was assigned on Tuesday, okay? Which was writing polynomials in standard form and make sure that you can classify by degree and number of terms. The second thing we did was we determined the end behavior of polynomial functions. So make sure you can do that and you know how to do that. All right. And then any of these problems that I assigned today. So today is going to be page 293. That handout I gave you the other day. I want you to do 8 through 34. You're going to do the even numbered problems. 8 through 34 even. Okay? So your study guide, page 293, 8 through 34 even, and then all problems assigned from page 285 on Tuesday. Good? Anybody have any questions on anything we've done today or anything we did on Tuesday? I know it's been a weird week, but everybody should get a really good quiz score this week. Yes, sir. I got them all cut, buddy. What do you think? Pretty handsome, huh? Appreciate that compliment. Yeah, yesterday was haircut day in my house.